Apart from the time complexity of an algorithm and checking if the sorting is in place or not, we also consider whether an algorithm is stable or not. So what does that mean? Well, it's a small thing. Consider an unsorted array with two elements having the same value 5. So I have marked them as 5 and 5 prime just to be able to distinguish the two numbers, although the numbers are the same, of course. Now, after the sorting is done on the array, if the result of sort is this, we call it a stable sort, while if the elements are arranged like this, we call this an unstable sort. And what is the difference? Well, the difference is that in case of a stable sort, the order of the elements in which they occur in a list or array is maintained even after the sort. Like in this case, 5 came before 5 prime in the original array, so that order is still maintained here. 5 still comes before 5 prime. Whereas if you look at the unstable sort, the order of equal elements has been changed, so that 5 prime comes before 5. That's it. So if you wrote your insertion sort algorithm like this, where we are moving the elements based on strictly greater than relationship, then if the element on the left is equal, it will not be moved. So for equal elements which were at the left will remain on the left side. This will make the sort stable. But if we made this slight change here and write greater than or equal to, the sort will become unstable, because now even if the element is equal to the current one, it will be moved to the right. And then the current element, which was originally on the right side, will come to the left. So be careful with stable versus unstable sorting, because at the face of it, although it doesn't seem to make much of a difference, but this example will help understand why stable sorts may be better. Let's say that on a web page, some data is displayed in the form of a table. And right now the data is not sorted according to any of the columns shown. Then let's say we click on the age column, which sorts the data according to the age. So that this is how the page may be showing the data now, alright? After this, let's say that the user wants to sort the data by name. So they click on the name column. Now there are two ways that the data may get sorted. Because the name Nancy Cooper appears twice, when we sort it, the sort may be stable or unstable. If it is stable, then because we had earlier sorted by age, hence Nancy with age 24 should appear before Nancy with age 28, and that is what we would like to see on the page probably. But if the sort was unstable, Nancy with age 28 comes before Nancy with age 24, which sort of messes up with the previous age-based sorting a little. So yeah, stable sorts do have some uses. So we would ideally want sorts to be stable, because for cases where it does not matter, stable sorts will not bring any harm, and where it does matter, they should be used anyways.